In figure 8.32, we have some data for heat-treated AISI 43-4E steel. And in this question, we will consider the data for the steel heat-treated to yield strengths of 800 and 1600 MPa. For each of these yield strengths, we will calculate the transition crack length AT, and also we will make some comments on the significance of these values. We know that the critical stress intensity factor is equal to the yield strength times pi times AT, which is the transition crack length. And when we make some arrangements, we can get AT is equal to 1 over pi times KIC over the yield strength and square of this. When we look at the figure, we can say that for the yield strength is equal to 800 MPa, we have AT is equal to 1 over pi times 187 MPa square root of meter over 800 MPa square, and it is AT is equal to 17.392 millimeters. And for the yield strength is equal to 1600 MPa, we have AT is equal to 1 over pi times, this time KIC is 41 MPa square root of meters over 1600 MPa square. And this will give AT is equal to 0.209 millimeters. Looking at these results, we can say that small transition crack length for a higher yield strength shows that material behaves more sensitive to brittle fracture as it is heat treated. So we can say that small transition crack length for higher yield strength shows that the material is more sensitive to brittle fracture as it is heat treated.